couple months ago when I had the beard. I don't have the beard right now. I misplaced it in Brazil. Don't know if it's going to come back or not. We'll see. Kind of missing it a little bit, honestly. So if you don't know me, I'm the director of GDK Software USA and a Delphi MVP. I have been in software development my entire life. I technically have 30 years of professional development, but I got a Commodore VIC-20 as a kid, and I knew programming is what I wanted to do. And ever since then, I've just been, if I'm not working as a professional software developer, I have been doing side projects. And when I'm working as a professional developer, I'm doing side projects. I just love figuring stuff out when it comes to software development. Worked in a variety of languages professionally, mostly Delphi. Delphi is definitely my favorite, but I've learned to appreciate pros and cons of all of them. So I might change this because this online slide, the slide advancement is really slow. If you're not familiar with GDK software, we have offices in the US, the UK, Netherlands, and Brazil. Over 25. Actually, we just added a new one today, so that number is probably definitely outdated. Delphi experts. And the cool thing about GDK software, actually, and this is one of the things I love about working here, is that we probably love Delphi just as much, if not more than you do, which is exciting because a lot of other consulting companies I've seen, they're like, oh yeah, we do all programming languages. So yes, we do Delphi. And I'm like, but do you really do Delphi? And I really feel like Delphi is like a state of mind, right? You just kind of have to love it. And that's GDK software. We love Delphi just as much as you do. So if you need Delphi consulting services, definitely check us out, gdksoftware.com. Also, we just recently announced Codolex 2.0, which is now free. It is a low-code solution for Delphi. Although I like to say it's more than low-code. It does quite a bit in improving your software development process. Has a lot of great benefits. Check it out at codolex.com, and it's now free, which, hey, that's pretty awesome. All right, I'm going to bring up my slides locally because this is running way too low on here. I'm not sure what happened. Well, I did test this in advance, but apparently it's maybe my slides are too big now. Hold on with me one second here, and I'm going to bring up my slides locally here so we can share my screen instead. I had to close PowerPoint, of course, to share the upload the slides. Slideshow. And oh, come on. I don't have my dual screen set up right now, so I'm trying to make this play nicely with running Restream at the same time. Definitely next time, dual screens are useful. Let me go ahead and throw up my other agenda set there. So this is the agenda, what I'm planning to cover here. And why am I not seeing? There it is. So let's change this to replace, screen share, window. All right, I think that's going to work now. Yeah, that should work. So now I can advance my slides locally and I can keep my chat window open. So one of the things in talking to people about this session and in preparing for it, I feel a little bit like I might come across as Chicken Little or the raving conspiracy theory nut. and that's part of the reason I added a lot of the background information that we're going to cover fairly quickly. That will be a great thing for you to check out more in the slides. But there's a lot of details that kind of emphasize why this is important. I've talked to a number of developers both in the Delphi space and outside the Delphi space, and as well as a cybersecurity expert about some of these topics. And one thing I found is that a lot of experts outside the Delphi space are really concerned about this. But inside the Delphi space, I feel like a lot of Delphi developers are like, "Oh yeah, Delphi's it's safe, it's good. We don't need to worry about it." But the reality is, security is really, really important. And so sometimes I feel like I'm preaching to the choir or chicken little, as I said. But at the same time, this is something I'm really excited about and really passionate about and think is very important. So yeah, I'm not crazy. This is important. Actually, my son just started recently working in cybersecurity. And I told him that one of the things about getting into technology work, and especially cybersecurity, is that you're going to feel a bit like the conspiracy theory nut, because you're going to see how important software is and how much software eats the world, as it were. It just powers everything. But then you're also going to see how tenuous some of the software is and be like, how is this working? This is concerning. And that's the reality of the world we live in, is that we're making the software that powers the world. But at the same time, we get to see that it's pretty amazing this works at all. And that's not trying to be a commentary on people's software, but it is, I've been doing software development for a long time, and it still feels like magic most of the time. So this all started with a report released back in February by the U.S. White House Office of National Cyber Defense. John and Paul from Perth. Sorry, I love seeing where everybody's from. Good to see you. Anyway, they had this report back to the building blocks, a path towards secure and measurable software. Pretty short report, but one of the things talked about is using memory-safe programming languages. And it also references U.S. Executive Order 14028 from 2021. Now, there's some criticism of this report. This was one of the articles I found that had some pretty good points in it, and definitely recommend checking it out. I love having the counterpoint, but it says that language selection alone isn't enough, and I agree. You definitely need education, which is the point of this webinar, is the education. You're already using Delphi, which is on the list of languages, but what do you need to know to be safer with your language? So yeah, like I said. So I wanted to put a little bit of a timeline here so that it didn't seem like the memory safety report was just this like random out of the blue, it just showed up. So, and Stuxnet kind of predates this. If you haven't heard about Stuxnet, check that out. But Stuxnet was a worm that infected Iranian computers, or Iranian SCADA systems, which were software running their uranium enrichment at a plant that was completely detached online. Essentially, Stuxnet is the first weaponized cyber attack. And you can read about it, but essentially my understanding is, and there may be some dispute, I'm not sure the U.S. ever claimed it, but the U.S. collaborated with some other countries and built this worm that they then had somebody from another country able to get there on a USB drive, because the plant was completely disconnected, and it destroyed their uranium, their centrifuge devices. So this is kind of the turning point where this is not the world pre-2010. After 2010, we're in a different world when it comes to software. Software has been weaponized. Okay. So you see here we have the WannaCry ransomware, not Pieta malware, which interesting was both powered by Eternal Blue, which was a exploit designed by the US NSA, but then was stolen from them and used to create these two big, huge attacks. Ransomware was huge for a few years. SolarWinds breach. I'm not going to go into details on all that, although I could talk about that a lot. A huge deal with that one as well. So we had a few of these big things here that illustrated to the U.S. government that, whoa, the U.S. government just did Stuxnet and weaponized software against other people. But now we've had these other attacks came in that have weaponized software against the U.S. government. So the U.S. government was like, okay, we need to do something about that, which brings us to Executive Order 1428 on cybersecurity, which the memory safety references that, kind of builds on that, is within that same umbrella, if you will. So, and I'm in the US and I'm talking about the US report here, but the EU also has a similar set of legislation around cybersecurity coming down, and Finland is actually ahead of the implementation requirements. So there are requirements coming down in Finland or in EU as well around software security. But I'm talking about it from the US here because that's the one I'm most familiar with. So a lot happened, and it's really important. So if you're not familiar with CVEs, CVEs is a system called the Common Vulnerability Exposure, and it's a way of documenting and sharing information about vulnerabilities. It's managed by MITRE Corporation, but is really the de facto standard. It's not a it doesn't, even though it's managed by a single company, it's not a single company initiative. For example, the US National Institute of Standards has a vulnerability database, and it uses the CVE records. So it gets some things from other sources as well, but most of the vulnerabilities the US government tracks come through MITRE CVE database. There also, if you're not familiar with Metasploit, is a tool used for cybersecurity testing. And what it does, it lets you, it's kind of crazy if you're not familiar with it. You can go check it out. But if you are doing penetration testing, which is where you're testing to see if a system is secure, Metasploit is a database of exploits. And you can go to a system and say, oh, this is running this version of Apache, and this version of Apache, I can look it up, has a CV, there's a vulnerability. And so Metasploit lets you run a exploit against a system to test to see if that system is hardened based on CVE numbers. It uses CVE numbers for that. It uses some things that don't have CVE numbers as well, but CVE numbers is the primary mechanism for that. So CVE numbers is kind of the industry, it is definitely the industry standard for vulnerabilities. So here are some memory safety CVE records you can check out as well. You probably heard about Heartbleed and Shell Shock and Stage Fright. They're pretty big ones. Here's a few others as well. The Android Out of Bounds Right was one for Android. And then this one here was one, there's a few that were Delphi related, so I thought I would include those as well. This was a buffer overflow in T-Picture. And here was a buffer overflow in Skype that was traced down to the implementation of the wide format string in Delphi as well. And then this is another one here that's not Delphi related, but these are CVE records you can go out check out that are related to memory issues. So Microsoft researched back in, this was just a couple years ago. I think it was more recent than 2018. I don't have the date that this was published on it, but they did a report where they talked about 2019 at a conference. Talked about some of the vulnerabilities that they were seeing, and they said 70% of the vulnerabilities that they had CVEs assigned for were related to memory issues. So just kind of indicating memory issues are a big deal across the software development. So another thing managed by MITRE is the Common Weaknesses Enumeration, CWE, which is a list of weaknesses, issues in software development in general. And they publish a top 25 every year. In the last 5 years, they have this list of stubborn issues, or stubborn issues that they see every year in the top 25. And so I went through and selected the ones that are related to memory issues. So we have out of bounds write, use after free, out of bounds read, null pointer deference, integer overflow. Not really memory, but I felt like it kind of fits in the same vein. And then improper restriction of operation within bounds of memory buffer. If you go out and check out the CWE database there at cwe.miter.org, they have on each of these, they go into details of it, and they also have information on mitigation. A lot of it is targeted towards C and C++, but the general concepts are useful to think about for your understanding of how these memory vulnerabilities work and why they're a big deal. But I was thinking about these memory vulnerabilities, and really they kind of come down to two dimensions. There's the dimensions of space and the dimensions of time. So time would be using unallocated memory or using memory after it's supposed to have been freed, whereas space would be like the buffer overflow, where you put more data into a buffer so than is expected. So if you're not familiar with it, this is a really big one that plagues C and C++, is the buffer overrun. In C and C++, the default string for the longest time has been the null terminator string. But if you, where you allocate so much memory for the string or for any kind of data, and the buffer overrun happens when you are able to push more data into that buffer, into that string, into that array, or whatever the memory structure is that you're storing data, then it has allocated. And what happens is that the data overflows out the end of that and then goes out and writes into other parts of the program memory. And if the person creating the exploit does it right, they can actually have they can change the instruction pointer. They can override enough that they can change the instruction pointer to point to the data, part of the data that they overran in the buffer. And so what they do is they put a bunch of just filler space in here until they get to the point that they can insert actual binary code. So they put binary code into instructions into that input that goes into the whatever the input of the program is, and then that then they put the instruction pointer to that binary code, and then what they've done is it's a remote code exploit where they've now put different functionality into the program, where then that program runs that functionality and at the level of privilege it has. So it's a great way to either just get access to a system, or once you're on a system and you've moved laterally to a program that has higher privileges, so it's running as administrator, to then have do things as administrator. So anyway, I just thought it was interesting that you could think about this in two directions, right? We have things about time, so if it happens before or after it should have been freed, and space, whether it is has to do with the space we've allocated for it, which of course made me think of TARDIS for all your Doctor Who fans out there. So the NSA had previously published a list of memory safe programming languages, and this was they'd done a report a while back talking about the importance of memory safety. And then shortly after the report came out by the other department, they updated it and added Delphi to the list, which was great, exciting. So there's excerpts from it here. They list the languages. They say even with memory safe languages, memory management is not entirely memory safe. That's a really important point, which is why we're here today, is to say, hey, even though you're using a memory safe language, you still need to think about how to do this properly. Languages vary in their degree of safety, which if we look at these languages here, definitely some of those, C# and Java, have way more guardrails in place for how you use it and how they make your memory safer. Also point out that memory safety can be costly in performance and flexibility. This goes to the premature optimization. Don't prematurely optimize. Sometimes I see people like, oh, I gotta squeeze every bit of performance out here. But the reality is they've sacrificed safety for performance that isn't going to have any real measurable impact in the way the software is used. And they also go on to point out some other things. that are useful in your safety. So this is, I just made a little chart comparing the different languages they listed here. Delphi is highlighted in red. It's kind of interesting in the list because everything else in the list, so Swift is a Apple offered product, right? That is their full suite of tools that compiles natively. C# is Microsoft's language of choice, right? And then Java is kind of a big player as well. And of those three, they're are really designed for full application development. So I indicate here that they have GUI frameworks, WPF, VCL FireMonkey, Java Swing, Java FX, and Swing. Actually, I guess there's probably more than WPF for C#, and Swift UI. The other ones don't have the GUI frameworks. And so I think it was interesting. Swift is natively compiled, for example, whereas Java and C# are not natively compiled. So Delphi and Swift are the only ones that come with GUI frameworks in the box, right? They are the full application development solution that are natively compiled. But Swift is really targeted to Apple platforms. There is limited support on Windows, I guess, for Swift as well. But I think Delphi in this list is kind of an outlier and in a good way, which is exciting for us because we're Delphi developers. So the question is C, C#, C++ really that bad? Why is everybody picking on C? Modern C and C++ does have a lot of memory safety features in it, but such as smart pointers, but there's so much of the instructions on how to use C and C++ and legacy code that don't utilize this, that it really is kind of dangerous. And so while C and C++ aren't bad, developers can be, which I'm a developer. So no offense to everybody, any other developers out there that maybe feel I'm picking on you. There's a few things that you may feel like I'm picking on you later on. But it's really about protecting developers from themselves. Java and C# were also developed to address C and C++ memory safety issues, specifically around memory leaks, which memory leaks isn't in the list of issues that they're trying to address in memory safe languages. So here's the part where I'm going to possibly offend some people. So trying to say this in a way that hopefully does not become offensive, but just remember there are exceptions. But I really, what I want to do is help you think about the way we write code and why it's important to have safeguards. So there's two types of code, roughly. And really, I think, honestly, there's two types of developers. You could say there's one developer that is in the application code camp, and another developer that's in the library code camp. But a developer can easily move between two. So you could say these are two different types of developers as well, or you could say it's two different types of code. So you have application code and library code. Application code is the majority of the developments out there. That's really, honestly, what Delphi is great at. Delphi is kind of this interesting space, honestly, because it's kind of like a low code. It was like one of the original low code solutions. But because Delphi is written in Delphi, all the libraries of Delphi are made in Delphi. So if you never feel like you're restricted in what you can do, and so you could always rewrite the parts that you don't like to add functionality that's not there. I knew a lot of people way back in the day that a lot of shops used Visual Basic, but Visual Basic, all the components in Visual Basic had to be written in other languages. And so you would see huge VB shops that would have a couple Delphi developers in there because Delphi was really good at making ActiveX controls, and Delphi would make the ActiveX controls that VB would use. Anyway, that's an aside. So yeah, you have application code, library code. I talked to a lot of Delphi developers, especially, that don't see themselves as programmers or software developers. They didn't study computer science in school. They instead had a business or saw a need for some software, and they're like, I need a way to make some software to solve this problem. and they saw Delphi was a great solution for that. And so they made a program and they solved that problem. And that is squarely in the application camp, right? It's not, it's you just want to get the problem solved. You're not necessarily focused on performance. You're not as focused on the some of the more nuances that show up in library code. Library code, it's very important that you think about how this code is going to be used. There's a measure of complexity called function points that has to do with like how code can be used to determine how complex it is, how much effort it takes to make changes, or how hard it is to change the code. And you look at an application, you look at like the buttons and the inputs and stuff like that, and how many different permutations of that determines the complexity of it. And application code, so if you go back to like old DOS programs, right? We had the program, you're doing one thing, you have one option at a time, and if you can't, edit multiple fields. You could, but originally you would just do one input, go on to the next input, next input. Very simple, not a lot of things can go wrong there. But then you look at a modern program where the user can change tabs, they can edit fields, they can hit different buttons while they hit this button, and the program is saying, please wait, they hit a different button, and then things get crazy, a lot more complicated. But library code is an order of magnitude more complicated than that. And so really, if you're making good library code, you really need to think a lot more about the robustness of it, the correctness of it. Testing is incredibly important. So both camps, clean code, best practices are very, very important. So I'm not trying to denigrate either side or say, hey, if you're doing application code, throw caution to wind and be crazy. But point out that in application code, you're really shipping productivity and getting it done is really your objective. Where in library code, over-engineering is a good thing, right? You still want to ship, but you want to make sure that it is right before you ship it. So I want to talk about FizzBuzz. If you're not familiar with FizzBuzz, originally it was like a game that you would play with your friends where you would count, and if the number is divisible by 3, so you'd say 1, 2, fizz. So instead of 3, you'd say fizz, and then 4, and then instead of 5, you'd say buzz, and if it's divisible by both 3 and 5, you would say FizzBuzz. So this was a programming example that was come up as like just a way to do a quick, simple program, get someone to write a simple program that's easy to comprehend, but then you can then look at their ability to deal with really basic programming structure. So here's an example of FizzBuzz in Delphi. Very simple. It's just a for loop and some if statements and some math. I used this when I was doing some interviews, and I had a couple developers that came up with totally different solutions. And this was a long time ago, and it really struck me as interesting. They're like, gosh, one was using, I can't think of what the term. Anyway, which that actually brings me to my next slide, which is the enterprise solution. So way back a number of years ago, someone in Java came up with the enterprise solution of FizzBuzz, which made heavy use of factory patterns. It was written in Java. It had 89 Java files, just ridiculous. But it is an example of some of the best practices that we see in enterprise software, where it's harder to get to the solution, even though the output of both programs is the same. The enterprise solution just is so much more intensive because of all these constraints we put on it. And so that kind of is an example of over-engineering that would fall into the library side, is some of this, how that can get in the way. And I did put up I'll put that in the chat here. I have a sample of the over-engineered Delphi version that is roughly 200 lines of code to accomplish what we just saw in about a dozen lines of code on the previous slide. And so you can see the, it isn't not going to LinkedIn. Interesting. All right. So if you're on LinkedIn, you're not going to get that link, but it's on the screen. You're not going to be able to type that in there, but it'll be in the slides. So make sure you registered, and put the registration link up here again. If I'm pointing in the right direction, hopefully I'm pointing in the right direction. It may have mirrored my slides or mirrored my camera, but hit the registration link and you can get the code. The slides will have that link in there. Kind of interesting to check that out. So what does all this mean? Most of the time, most of us are writing application code, but I call this the curse of the programmer, is that we're like, hey, this could be a component. This could be reusable. I should over-engineer this simple solution instead of creating a report. Instead, I'm going to create a reporting framework, right? This is part of the way I feel like our brains sometimes work as software developers, that we want to over-engineer it. And this goes to the premature optimization advice, right? So often we spend way too much time trying to optimize some code before we've benchmarked it, before we've profiled it. And so what profiling does, right? We could optimize some chunk of code, and then without profiling it, without knowing how that execution of that code impacts the user experience, we could put way too much effort into improving the performance of this code, only to find out the user only hits that code once a day. And so we've shaved off a millisecond or a whole second off this code to only find out that a tenth of the users hit it once a day. And so the benefit of that was minimal. So don't prematurely optimize. And I think a lot of times it's really easy for us to over-engineer things and prematurely optimize it. So use safeguards, write clean code, unit test. Think about what it is you're writing. Are you really writing a library, or are you really writing application code? If you're writing application code, shipping is a very important feature. So is Delphi memory safe? Yes, although it wouldn't be on the list, but that's why we're here today. We're going to talk about how Delphi addresses some of these memory safety issues and how we can use those better. So buffer overflows and underflows. This is like the big one, is because even before Java and C#, which they also addressed this, Delphi had the string, the default string we have is the long string that automatically allocates the memory it needs for whatever you put into it. Which in C#, I know at least, I can't remember if Java does, a lot of the languages, though, they have the idea of immutable strings for performance purposes, which, yes, that makes sense, right? So the string doesn't have to keep reallocating itself. But I think so often people are prematurely optimizing it, but that's a whole other rant we could get into. So, but Delphi has strong typing and array bounds checking and the dynamic strings. So it is out of the box able to handle buffer overflows and underflows much better. Use after free and double free vulnerabilities, which is that time swipe. So that the previous one was the space axis. This is the time axis. With Delphi, if you make use of interface reference counting, then it goes away for you automatically. Minimizing the scope. This is a really, really, really important thing. Kind of just a general best practices that you don't want your variables to be available in a larger scope than necessary. And honestly, the inline variables that were introduced in recent versions of Delphi have a huge, huge, huge benefit for this, because you can have, like in a loop, you can have a variable declared in that loop that then is not accessible outside that loop. And so there's no chance of you using that in a situation that it's not meant to be used. And again, and this goes back to in application code. Let's see, there's a tip in software development, is that the first time you're writing the code is when you understand what you're trying to accomplish the best. But then the reality is code spends way much more time in maintenance than it does in the initial development. And when you're coming back and looking at that code a day later or a year later, you have to rebuild that structure of what you originally were thinking when you wrote that code. And so you never want to write code at the peak of cleverness, right? You don't want the code you're writing to be the peak cleverness, because you're never going to have that level of understanding of what you're trying to accomplish again when you're looking in that code. And so you're not going to have you're making it harder on yourself or whoever else is maintaining your code. So minimize references. So yeah, what I was trying to say with that is that while you're writing the code the first time, you may think it's, oh yeah, a global variable. I know exactly what I'm doing with this global variable. But then the problem is in the future, when you're editing your code, right, that you don't remember what you originally were thinking. And so having variables available in larger scope introduces a lot more trouble in the maintenance department. It's a technical debt, I guess you could say. So having it in the minimum scope possible prevents in the future when you're editing the code from doing things that you shouldn't do. The compiler prevents you from having that. I've talked to a number of developers that went through and essentially refactored their code after inline variables were introduced to use inline variables more. And they discovered a lot of places that they're like, oh, I was using this after it was freed, or I was using this code, this variable in a place I shouldn't have been using it, but because it was visible in a larger scope than it should have been, wasn't a global variable, but it was, within a routine, was more visible than it should have been. They had problems, and they weren't discovering them because of, the flow of the code. They didn't hit that code very often, and so they didn't know that they were having issues until they switched to inline variables, and the compiler said, "Whoa, you're referencing this when you shouldn't." Improper memory access is where program access is uninitialized or freed. So kind of similar to the other one. So again, Delphi's string types, dynamic arrays, managed types, etc. Improve this. Also, the generic collections allow you to have a collection where the type information is preserved, right? So if you're not a generic collection, you're just using a regular T list and things, and you pull it out and you have to cast it, you could cast it wrong, right? Hopefully you're not storing multiple types of objects in a single T list, but if you are and you pull it out and you cast it wrong, that's a problem. So generic collections are a great way of enforcing that. Again, that of course you know what you're doing when you're writing the code, but later on when you or somebody else is maintaining the code, having that hard coded essentially is a great way of preventing that. And memory leaks. Again, this isn't a safety issue because it doesn't necessarily lead directly to vulnerabilities like buffer overflows. Buffer overflows are huge for this, but a memory leak can produce instability, and instability can cause not only performance degradation, but could also cause trigger a program to do other things that could lead to other exploits. So Delphi doesn't have garbage collection like C or C sharp or Java, for example. It's got a hybrid model though. Interfaces and records are automatically managed, and it has the tri-finally blocks and other mechanisms you can use to manage your memory to prevent memory leaks, which I'm going to talk about more in a little bit here. And I'm running a little late on time. Okay, yeah, so we're talking about best practices for memory safety, the good stuff. All right. The basics, I don't think any of this is going to be controversial for people. Always use minimal scope, better for inline variables like I just talked about. If you create an object, the code that creates the object should be responsible for freeing it. If you're sharing an object with another object or system, generally the rule of thumb is whatever system created it should also free it. There may be exceptions where it specifically says, hand off this object and this other object will free it for you. But that's kind of a good practice. Any reference that you have that is visible in a broader scope, if you free the object, nil it. Free and nil is your friend. And I know that some people argue about whether or not you should have that at all, but I think it is a good thing for usability or for codes for safety. And you could argue that if that is the situation where you do have a variable that is visible in a broader scope that could be nil at the time, that's a design issue. And so that may be something you could look at it from that point of view. If you create it in the constructor, free it in the destructor, and use try finallys, address all hints and warning. That's probably the hottest take here. I am guilty of this, of writing code and being like, why isn't this working right? And then finally looking down and seeing there's a hint from the compiler saying, hey, Jim, you made a mistake, and it fixes it. But so many times I've had people come to me and say, I'm having some trouble. Can you look at this code with me? And I look at it. And I look at it, and there's a ton of hints and warnings. And I'm like, that's a lot of hints and warnings. I'm like, yeah, I know, but they're just too hard to keep on top of them. And we look at the hints and warnings, and there's a hint and warning exactly telling them how to fix the problem they're experiencing. And I see Mason just commented, as Nick here, I can just see his eye twitching when he say that. Yes. Free and nil. So if a variable is accessible in a larger scope in a state when it could be not allocated, it's probably a design issue, right? So it's a code smell. Fix that. That would be Nick's position. Nick thinks free and nil is wrong. Again, I think it's a code smell. It's an issue that if you're doing that, you probably designed the application wrong, and you need to change your design. But if you have to have a variable that is accessible in a non-initialized state outside of in a broader scope, then use free and nil. I think Nick would agree with me on that. Okay, so this is a pattern not all people are familiar with, but we're familiar with try finally. But if you're creating multiple objects, so here I have 3 objects, and I could nest it in 3 try finallys, but that's like, there's a little bit of overhead in the try finally. That's not the best way to do it. So with this, because a destructor, free is not virtual, right? Destroy is virtual. Destroy can be overridden by a descendant object, but free is not. Free is implemented in T object. So this example is being T object is not as useful, but imagine this was something else besides T object here. Because of that, if object 1 or object 2, right? So if, let's say, an exception occurs here, right, in object 2's constructor, or maybe there's something that happens right after object 2's constructor before object 1 is created here that causes an exception, and we jump down to finally. And so we're in finally in a state where object 1 hasn't been created yet. Because object 1 has been initialized to free or to nil, it is safe to call free on it. So this is why free and nil is not a bad thing, right? So yes, it might be a code smell if you have to use free and nil, but a object reference that is set to nil is safe, okay? If you try and do something else with it, the compiler will give you an exception. And if you call free on it, the compiler will say, okay, we're fine, we're good to go. So yeah, this is a useful pattern if you are creating multiple instances of an object and you don't want to have nested try finallys. So I saw Paul had, can we stage talk about what the process of free and destroy or where is the best to find out? If you go to this DocWiki link here down at the bottom on methods in Delphi, there's a section on constructors and destructors, and I pulled this from this, and it goes into a little more detail here. But when an exception is raised during creation of an object, destroy is called automatically to dispose of the unfinished object. So within a object, the fields, right? So right here we have fpin that we're in the constructor we're creating with tpin.create. Let's say we had a list of objects that we're constructing in there, and one of those or something happens before all of them are initialized, right? Then it's going to jump straight to destroy. And you see here, I'm freeing both brush and pin here, which I didn't include brush in the constructor here for simplicity's sake. But because brush is a field member of the T-shape object, it is initialized to nil. So a variable that you declare in a method is not initialized to nil unless you explicitly do. So we looked at that in the previous slide. But anything that's a field member of the object is initialized to nil. The object gets initialized to nil, or all the field members of an object are initialized to nil. So this is safe to call these frees. So hopefully that answers your question, Paul. But the class type and pointer type fields in partially constructed objects are always nil. So you also need to check for nil values before operating on class type or pointer type fields. Yeah, so you always want to call free instead of destroy, because destroy is overridden in descendant objects. It's virtual, whereas free is not. Free is always going to execute because it's going to execute on T object, and it is and it calls the destructor if the object reference is not nil. Hopefully that made sense. Okay, so gosh, we're running out of time. If you have questions, go ahead and put the questions in the question panel. I will stick around and answer questions as long as people are here. Sorry we had the rough start, but address-based randomization, this is a fairly new feature. Or no, this has been around for a little while. I can't remember when this was introduced. But dynamic base, it enables address-based randomization on Vista and newer, so that gives you an idea of when it was introduced. What it does is it changes the location of things in memory, so that if someone does try to attack the memory of a program, that it's not going to be running in the same space every time, which makes it a little harder. Not perfect, but it makes it harder, and it's free to turn that on. So make sure you're using that. I can't remember if that's on by default. High entropy 64-bit is a very new feature that is it basically extends the address-based randomization to make it more random. So if you're compiling for 64-bit on Windows, check that one out. Data execution prevention. This was introduced quite a while ago. It's on by default in Delphi. But what it does is it prevents, so I talked about the buffer overflow, where you inject executable code in data of an application. So what data execution prevention does is it prevents that code that was injected into the data part of the memory of the application from ever being executable. It's on by default, but you can turn it off if you need to. And there's also a place in Windows where you can turn it off for certain programs. So by default, on for all programs, but you can say, okay, on for all programs except this one, if there's some reason to do that, which I'm not going to go down that path because we don't have time. So here's my controversial advice. Leave runtime checks enabled in production. All right. Yes, this is controversial. If you read the documentation, it says to turn it off because of the performance impact. But I would argue that doing that by default, which is what default Delphi does, of turning these off in production, is premature optimization. Most of the time, or often, maybe, it's not going to make a measurable impact in the performance for the user's point of view. But leaving it on does make your program safer, right? So leave it on by default. And then if after you benchmark it, after you do your profiling and say, oh, this routine right here is called a lot and it's a little slow, then you could look at turning off the checking in that one spot, right? And if that makes the difference, then there you go. There's a great optimization you could make that can then do that. And then you take that one piece of code and you look really hard at it to make sure that it is safe, even though you're not relying on those runtime checks. Here's an example of what the disassembly view looks like with the range checking turned on turned off versus on. So we definitely see there's more routines here. But if you look at this, it's doing a comparison right here, and it's saying, hey, if it fails, then we're going to do other things. So the comparison is the overhead. That's the biggest part of the overhead. So again, it's going to vary from case to case in what you're doing and how you're using it and how the code's being used. But turning these off is premature optimization, and you're just it's not, I don't think it's a good practice. But disagree with me and argue with me on this point. I'd rather have a conversation about this and get everybody thinking about what this means than just blindly following some advice that is in the doc wiki. Going further, read Delphi Memory Management by Dahlia. Dahlia did pipe in on this art on the when the list was published of saying Delphi is memory safe, and she said, no, Delphi is not memory safe. She is definitely an expert on this, but I would say Delphi is memory safe or safer than some other languages out there, and I think it does belong on the list, but it is not. And if you look at the list, it says not all languages have the same safety. The safety does vary, but I think it does belong on the list. So I will disagree with her on that, but I will still recommend her book. Everybody I've talked to that I've recommended this book to that has gone and read it, they're like, oh my goodness, I've been writing code wrong my entire life. So check it out. It's a great book for helping you understand memory management in Delphi. Make use of records, interfaces, smart pointers, and auto release pools. Dahlia has a blog post on auto release pools. And then Spring4D has some smart pointers in it as well. Check that out. And then FastM has report memory leaks on shutdown. And I would say use it during development, but don't ship with it. But you might have an option to put your application in a debug mode where you can check that out. So here's the example of the auto release pool. You have just take auto pool and you add objects to it. And then when that pool goes out of scope, it frees the objects that have been added to it. So great way to prevent memory leaks without having to have the overhead of try-filing blocks. Jedi JCL has the safeguard as well. So you can check that out. And the multi-safeguard. And here's some links on Spring4D. Spring4D has got so much stuff in it. It's one of those kitchen sink libraries, if you will, that has a lot of things in it. But there's some details on it. There's a video on installation, a video introduction for it. That actually I took that video and I've got a transcript and I'm going to chop it up into smaller chunks and make it more accessible because there's a lot of good information in there. But it's an hour-long video. It's a little hard to digest. But go out to Bitbucket and grab it. There's a wiki in there as well that has a little bit of information. There's the documentation that lists all the methods and their parameters, but doesn't really talk about the usability. The usability, if you're like, I know nothing about Spring4D, check out that introduction video there, and then also have a blog post that goes into more details too. And then there's some support options. There's the official support platform is the Google group, but Stefan writes about it in his blog occasionally, and he hangs out on Delphi Praxis, but there's also a Spring4D tag on Stack Overflow. So here's an example of Spring4D's shared T, which is a smart pointer. And so we have, actually, I'm going to skip to the next one because I am over time. I shared T. So the cool thing about this is that you create it here by calling shared.make, and then it gives you this iShared, a interface reference to T-string list. And the class name of SL is going to be T-string list. And if you can access the members of the T-string list directly. So I guess I need to talk about this one to show why that's interesting. In here, the shared T-string list, you have to call value in order to get access to this T-string list contained in shared, whereas with the iShared of T, you don't. It gives you that directly. Dahlia actually has a smart pointer reference or implementation in her memory management book as well, but Spring4D is a great option and has a ton of other great things in there as well. There's an option to include a finalizer so that if you want to do some things in addition to freeing it when it goes out of scope. So in this case, it doesn't just free it, it calls this finalize routine that you've put in here when it goes out of scope, where you can do other things if you wanted to before it's freed. And this could be especially useful if you have a other type of managed resource like a handle or something that you need to take care of. And then also there's week of T, which gives you a week reference. You can check that out too. And we're over time. So the only question I saw Paul had a question about let's see, more tools. Okay. Gosh, I really must have rushed because we're just barely over, and I know I had a really rough start here. Eureka Log and Deleaker are useful tools in tracking down memory leaks. Deleaker is focused on memory leaks. Eureka Log is there's Eureka Log and MadAccept. Should have included MadAccept on here as well. But other tools in that space, there's one that's in Jedi 2 that gives you this ability to capture a more detailed debug information when your application is deployed. So it gives you the ability to have an application running on your user's computer, grab some information in a failure case and give it back to you so that you can better understand why it failed. TMS Fix Insight adds more hints and warnings, which is a good thing. Fix the hints and warnings you're already getting, and then use Fix Insight to get even more, because that's going to make your code safer. DIR Scanner is rather expensive, but it is a static code analysis tool focused on security issues, focused on those CWEs. I believe they use the CWEs specifically in the report. And they're like, whoa, this is this CWE, and here's how to fix it. And then also check out SonarQube for Delphi, which is another static code analysis tool. When will the materials be sent? They will be sent. I will have at least some of them sent later today, but I'll probably be revisiting this in the future. Okay, so real quick, again, wrap up here. GDK Software, I run GDK Software USA. If you're like, oh my goodness, I need to make my code better, talk to us. This is what we do. This is what I do. I love doing this. It's exciting stuff to me. So we have offices, like I said, around in different countries, and 25 plus Delphi experts. So check us out at gdksoftware.com. If you haven't registered for Delphi Summit, register for Delphi Summit. It would be great to meet you there in person. I had a lot of people there messaged me that are really excited about that. And honestly, I really love meeting everybody too. So it's great. I'm very, very excited about that. And again, if you didn't register for this, if you're watching this and you haven't registered, go to that link there, mailing.gdksoftware.com/webinars, sign up. We have more webinars coming in this series. I think that schedule's fairly set in stone, but it is subject to change and open to suggestions. So if you have other suggestions for webinars, let me know, and I would love to include them. And yeah, now we're doing Q&A. Answered, when will materials be sent? Soon. Hopefully today I'll have some of them sent out. And then Paul, you did ask about the process of free and destroy. Hopefully I answered that. If not, let me know, and I'm happy to talk with you about it more. You can leave a question now, or catch me later. With that, gosh, I feel like I did kind of cram stuff in here, and my apologies. We did run over a little bit, but I really wanted, honestly, a big part of my goal with this was to start a dialogue, a conversation, help us to think about about this more, and think about how we can think about whether or not we are giving as much attention to this as we want to. Just saying, hey, Delphi's on the memory safe list, I don't have to worry about it anymore. That's not a good thing, right? We need to also use best practices. We need to also consider how we're writing the code and using some of the practices I talked about here. And no one's in the chat said anything about that. So apparently it's not too crazy of a suggestion to leave those runtime checks on during production, right? Don't turn them off, leave them on. It's better to have it. So this is way back in Windows 3.1, if a application had an exception, it could crash the entire operating system. And this was one of the things that Delphi introduced in the Delphi 1 presentation for Windows 3.1, was that a Delphi application had exception handling, right? If an exception occurred, I think it was a divide by zero, Anders Halsberg did intentionally, which now actually I think the compiler will warn you if it's obvious going to be divided by 0. You can still get divided by 0, but the application had an exception handler built into it that would prevent it from taking down the entire operating system, right? That's a huge improvement. But the problem I see some people doing is they see some people trying to hide exceptions and trying to just eat all the exceptions and log them or something like that. And that's a bad thing, right? You want, if an exception occurs, if there's something that happens in your program that you were not planning on happening, then your program is now in a bad state, right? And it may need to be restarted. So if you can't fix all your exceptions, then it's okay to tell your user you need to restart now because something went wrong. That is better than telling your user everything's okay, keep going, and then having the data be bad, having something happening wrong in your program. So a suggestion came in. Would there be a possibility for a webinar about REST and SOAP in Delphi? Yes, but that's a really broad topic. So yeah, send me an email with what specifically you're doing, and I'll add that to the list and you definitely do. I haven't done SOAP in a while, but I certainly could do REST. And I could do something on SOAP as well. But if there's specific things you'd like to see covered, then let me know. Yes, Mason, Pokemon exception handling, got to catch them all. Ideally, it would be great if you caught and handled explicitly every exception. But the try except with the except block that just catches everything and just says, I caught it, not a good thing, right? You want to catch as specific an exception as possible and then deal with that exception situation, not just say, I caught it, I wrote it to a log file, keep going. Because if you do not specifically understand what could have caused that exception to happen, you have the problem that now your program is in an unknown state, a state where the data is not good or could potentially not be good. And so again, you're better to not handle the exception and say, hey, restart the program. Then, and actually, so that is a downside of Delphi's global exception handler, right? Is that it bubbles up and the global exception handler says, caught it, display a message to the user and lets the user go. But the program could be in a state that it is now broken. And so you probably want to use something like MatExcept, like Eureka Log, that replaces that, or the one in Jedi that replaces the global exception handler, and then tells the user, you might need to restart, right? Here, send me this detail about this and I'll fix this exception, but you might want to restart now because the program might be in an unknown state. Paul says, great presentation to us on double freeze. We'll find the leak. Okay, great. Yeah. Didn't get into much detail on that, but that can be, yeah. Okay, well, thank you so much for joining me for this webinar. If you didn't register via the registration link here, hopefully I'm pointing in the right direction. I will watch the replay and see if I'm backwards and mirrored, but click the registration link, and actually I'll throw up the, I know that's at the bottom, right? Go to the mailing gdksoftware.com/webinars and register for the series. More webinars coming. And yeah, my name's Jim. Hopefully you've enjoyed this. If you do have feedback, drop me an email as well. You should have my email address when you register, and I would love your feedback. If I've discovered that sometimes I have a hard time making things at the right level. So if this was way too high a level, let me know. If this was way too low a level, let me know. Yeah. So thank you for joining me, and I look forward to seeing you at Delphi Summit, hopefully, and if not, seeing you at future webinars in the series. Take care, everybody.